Hi, it's Jin Young, and today I'm going to talk about the Pythagorean Theorem. The reason I chose this Pythagorean Theorem is because we had a problem where we had to use this to get the correct answer, and it was supposed to be in 7th grade math, so some of you didn't know it or didn't really understand, so I just wanted to make a video. Okay, so how it was made. It all started with this guy Pythagoras. His name was Pythagoras because of who knows why reason. Cause it could have been Bob or William or I don't know. But it is Pythagorean theorem. I mean, it's just out of his name. It's a theorem that Pythagoras made. So what he found out is that there are several stories, but I heard this one the most. So one day he was just looking at the tiles of a neighbor's house. I don't know why anyone would spend the whole day looking at tiles, but he did. And then he was looking at the tiles, and then tiles have this square shape. And then out of nowhere, he just noticed this right triangle. And then thought of this. A squared plus b squared equals c squared. I'll explain this as we get further. So Pythagoras was thinking that this was leg A, this was at leg A, and then this was leg B. And then this was the hypotenuse C. When it was a right angle. It can't be like an obtuse triangle or even a acute triangle. It has to be a right triangle, 90 degrees. So he thought of this. Yeah. So what I think is that he just tried it on, and then he tried it on some other triangles, and then it worked the same way. So for this to be true, it needs to work on every single right triangle. It can't just work on this one and not work on this one or whatever. It has to work on every single one. Okay, so this is the Pythagorean theorem. For any right triangle with sides A, B, and hypotenuse h, the square of the hypotenuse is equal to the sum of the squares of the other two sides. Well, here it put H, but normally we put C because of just the alphabet order. So you can just think of it as C or even H. Doesn't really matter. It's the same thing. So what does this actually mean? So, squares. A square is a rectangle. To get the area of the rectangle, you do length times width. But in a square, this is length. If this is length and this is width, length is the same thing as width. So it will be either this or either this. So if this much was a, then it will be a squared. So let's just say this is this and say this. Don't show. This was a squared. It's not anything difficult. It's just the area of it. And then another one we had B. The side of it was B. And then to get the area of this square, you would have to times length times width, which is length is B and width is B. So B times B, how to make it simpler? B squared. So this is B squared. And then there's the other one. This might look kind of confusing because it's tilted like about 49 degrees, I don't know. And still it's the same thing. If you put it back and then it's like that, then this is gonna be H, this is gonna be H, the same way this is gonna be H squared. See? It's not complicated. And what do you mean by this? It means it's really simple. It's not anything hard. It means this area equals to this area plus this area. So this is this plus this. How simple is that? So we need to have an example, right? So say that this much is 4 units. So yeah, and then that much is 3 units. And as you can count, this is 5 units. So let's see if Pythagoras was actually right. Okay, so let's start with the smallest. So the area of this, you can just count the squares. 1, 2, 3, 4, 5, 6, 7, 8, 9. Or you could just do this. So this is 9. And for this one, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Or you could just do this. And for this is 5 times 5. So 5 squared is 25. Or you could just count. So now we know that this area is 25, this area is 9, and this area is 16. So to check if the theorem is correct, we need to add this and try to find out if it equals to that. So 9 plus 16 is 25. Oh my gosh. Oh my goodness. We got 25. But doing only one doesn't really fit the theorem. It doesn't really qualify. It doesn't mean the whole thing is right, does it? So now if you look at this example, it's 1 and 1 and root 2. Root 2, does everyone know? Root 2 is that if you square root 2, it's 2. So to get the square out, you need to root. Yeah, so the area of this would be that, so it would be 2. And this is really easy. This is 1 times 1, and it's 1. And this is also 1 times 1, and this is 1. So is 1 plus 1 2? This is a kindergarten problem. Yes, it is true. And if you do this for any other triangles, right triangles, it will work. That's why this theorem is correct. And everyone in the world uses it. And then if you continue on and do harder math, you'd have to know Pythagorean Theorem. Otherwise, you'd take a really long time and you won't be able to solve it. So even if it's a bit complicated, it's really good to try to know and learn and understand the Pythagorean Theorem because it will be really helpful like when you do more difficult math. Thank you.